The results of the recent NFPA 70 National Electrical Code Convention are now available and can be found online. There were a number of significant changes made to the code, including new requirements for arc fault circuit interrupters, often referred to as size, in all residential occupancies. These devices are designed to protect against fires caused by arcing faults, which can occur when damaged or deteriorated wiring creates an unintended electrical path. SIs are different from standard circuit breakers in that they detect arc faults, while circuit breakers primarily protect against overloads and short circuits. The code now mandates their installation in more locations within residential buildings to enhance fire safety. Updated requirements for ground fault circuit interrupters, commonly called GFCIs, in all wet or damp locations were also implemented. GFCIs are crucial safety devices that protect people from electric shock by detecting ground faults, which occur when electricity flows through an unintended path to ground, such as through a person. GFCI protection is required in areas where water is present, like bathrooms, kitchens, and outdoor receptacles, as water significantly increases the risk of electric shock. The updated requirements likely expand the specific locations where GFCI protection is necessary, reflecting an ongoing effort to minimize electrical hazards in damp environments. There are new requirements for the installation of photovoltaic, often referred to as PV, systems. With the increasing adoption of solar energy, the NEC has introduced specific regulations to ensure the safe and effective installation of PV systems. These requirements cover various aspects, including wiring methods, overcurrent protection, grounding, and disconnecting means. The goal is to address the unique challenges associated with PV systems, such as direct current voltage levels, backfeed of power into the grid, and potential fire hazards. Updated requirements address the installation of electric vehicle charging stations. The growing popularity of electric vehicles has led to the need for standardized and safe charging infrastructure. The NEC includes requirements for the installation of electric vehicle supply equipment, commonly called EVs, which covers aspects such as wiring methods, overcurrent protection, grounding, and control circuits. These requirements aim to ensure that electric vehicle charging stations are installed safely and can handle the increased electrical loads associated with EV charging. There are new requirements for the installation of energy storage systems. Energy storage systems, such as batteries, are becoming more common as a way to store electricity generated from renewable sources or to provide backup power. The NEC includes requirements for the installation of energy storage systems, addressing issues such as battery type, location, ventilation, overcurrent protection, and disconnecting means. These requirements are designed to prevent hazards such as fires, explosions, and electric shock associated with energy storage systems. In addition to these major changes, there were also a number of other smaller changes made to the code. These changes can be found in the online version of the code. The new edition of the NEC will become effective on January 1, 2008. Let's delve further into the specifics of each of these significant changes. Firstly, considering the new requirements for arc fault circuit interrupters, or SIs, the updated code likely specifies the exact locations within residential occupancies where these devices are now mandatory. This may include areas such as bedrooms, living rooms, dining rooms, and other habitable spaces. The NEC Article 21 typically addresses branch circuit requirements, and this section would likely be amended to include the specific SI requirements. The code may also differentiate between different types of SIs, such as branch/feeder SIs and outlet branch circuit SIs, and specify where each type is appropriate. Furthermore, the installation requirements may address the proper wiring methods, grounding, and testing procedures for SIs to ensure they function correctly. The updated requirements for ground fault circuit interrupters, GFCIs, built on the existing GFCI protection requirements in wet and damp locations. The changes may expand the definition of what constitutes a wet or damp location, potentially including areas previously not considered to require GFCI protection. For example, the updated code might include specific requirements for GFCI protection in crawl spaces, unfinished basements, and certain outdoor areas. NEC Article 406 typically addresses receptacles, and this section would likely be updated to reflect the expanded GFCI requirements. The code may also clarify the requirements for using GFCI circuit breakers versus GFCI receptacles and specify the testing procedures for GFCIs to ensure they are functioning properly. The new requirements for the installation of photovoltaic or PV systems likely address a wide range of safety and performance considerations. This might include specific requirements for the sizing of conductors, overcurrent protection devices, and disconnecting means to handle the high direct current or DC voltage levels associated with PV arrays. The code may also address the grounding and bonding requirements for PV systems to minimize the risk of ground faults and electric shock. Furthermore, the updated code may include requirements for the location and accessibility of PV system components such as inverters and combiners to facilitate maintenance and emergency response. NEC Article 690 typically covers solar photovoltaic systems, and this section would be extensively revised to incorporate the new requirements. The updated requirements for the installation of electric vehicle charging stations (EVs) cover various aspects of the charging infrastructure. This includes requirements for the sizing of conductors and overcurrent protection devices to handle the high current demands of EV chargers. The code may also address the grounding and bonding requirements for EV charging stations to ensure electrical safety. Furthermore, the updated code may include requirements for the installation of EV chargers in different types of locations, such as residential garages, commercial parking lots, and public charging stations. NEC Article 625 typically covers electric vehicle charging systems, and this section would be updated to reflect the new requirements. The new requirements for the installation of energy storage systems, such as batteries, address the unique safety challenges associated with these systems. This includes requirements for the type and location of batteries, ventilation, fire suppression, and disconnecting means. The code may also address the overcurrent protection and control requirements for energy storage systems to prevent overcharging, overheating, and other hazards. Furthermore, the updated code may include requirements for the labeling and signage of energy storage systems to provide clear information to installers, users, and emergency responders. NEC Article 706 typically covers energy storage systems, and this section would be revised to incorporate the new requirements. The effectiveness date of January 1, 2008 is important because it means that all electrical installations after this date must comply with the new requirements of the 2005 NEC. Electrical inspectors will use the 2005 NEC as the basis for their inspections, and any installations that do not comply with the code may be subject to rejection or require correction. It is crucial for electricians, contractors, and other electrical professionals to familiarize themselves with the new requirements of the 2005 NEC to ensure that their installations are safe and compliant. Furthermore, it is important to note that the NEC is typically updated every 3 years, so the 2005 edition was eventually superseded by subsequent editions such as the 2008, 2011, 2014, 2017, 2020, and 2023 editions. Each new edition incorporates changes and updates to reflect advancements in technology, new safety concerns, and evolving industry practices. Therefore, it is essential for electrical professionals to stay current with the latest edition of the NEC to ensure that they are using the most up-to-date information and best practices. The NEC is a comprehensive document that covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installations. To effectively use the NEC, it is important to understand its structure and how to navigate its various provisions. The NEC also includes numerous tables and examples that provide practical guidance on how to apply the code in different situations. These tables and examples can be invaluable tools for electrical professionals who are seeking to understand and comply with the code requirements. The NEC is not a static document. It is constantly evolving to reflect changes in technology and industry practices. The NFPA which publishes the NEC, solicits input from a wide range of stakeholders, including electrical contractors, engineers, manufacturers, inspectors, and users. This input is used to develop proposed changes to the code, which are then reviewed and voted on by the NEC Correlating Committee and various code-making panels. The NEC is a consensus standard, meaning that it represents the collective judgment of a diverse group of experts. This ensures that the code is both technically sound and practical to implement. The NEC is widely adopted throughout the United States and is also used as a model code in many other countries. It is an essential resource for electrical professionals who are responsible for designing, installing, and inspecting electrical systems. By following the requirements of the NEC, electrical professionals can help to ensure the safety and reliability of electrical installations. Let's consider a specific example of how the new requirements for size might be applied in a residential occupancy. Suppose a new home is being constructed, and the electrical contractor is responsible for installing the wiring and devices. Under the 2005 NEC, the contractor would be required to install size in all branch circuit supplying outlets in the bedrooms, living rooms, dining rooms, and other habitable areas. This means that the contractor would need to use size circuit breakers in the electrical panel to protect these circuits. The contractor would also need to ensure that the size are properly wired and grounded, and that they are tested to verify that they are functioning correctly. If the contractor fails to install size in the required locations, the electrical inspector would likely reject the installation and require the contractor to correct the deficiencies. This could result in delays in the project and additional costs for the contractor. Similarly, let's consider an example of how the updated requirements for GFCIs might be applied in a commercial building. Suppose a restaurant is being renovated and the electrical contractor is responsible for installing new receptacles in the kitchen and bathrooms. Under the 2005 NEC, the contractor would be required to install GFCI protection for all receptacles located within 6 feet of a sink or water source. This means that the contractor would need to use GFCI receptacles or GFCI circuit breakers to protect these receptacles. The contractor would also need to ensure that the GFCIs are properly wired and grounded and that they are tested to verify that they are functioning correctly. If the contractor fails to install GFCI protection in the required locations, the electrical inspector would likely reject the installation and require the contractor to correct the deficiencies. This could result in delays in the project and potential liability for the contractor if someone were to be injured due to an electrical shock. With the implementation of new requirements for photovoltaic or PV systems, it is important to consider the specific challenges of PV installations. Suppose a homeowner decides to install a solar panel system on their roof to generate electricity. Under the 2005 NEC, the installer would be required to follow specific guidelines for wiring the PV array, including using appropriately sized conductors and overcurrent protection devices. The installer would also need to ensure that the PV system is properly grounded to protect against ground faults and electric shock. Furthermore, the installer would need to install a disconnecting means to allow the PV system to be safely disconnected from the electrical grid. The 2005 NEC also brought about updated guidelines for the installation of electric vehicle charging stations. Suppose a business owner wants to install an EV charging station in their parking lot to attract customers with electric vehicles. Under the 2005 NEC, the installer would need to follow specific guidelines for wiring the EV charging station, including using appropriately sized conductors and overcurrent protection devices. The installer would also need to ensure that the EV charging station is properly grounded to protect against ground faults and electric shock. Furthermore, the installer would need to install a disconnecting means to allow the EV charging station to be safely disconnected from the electrical grid.